All right, you're in the right place if you're looking for the second half of lesson 1.2. We're working through this little function section. I want to encourage you to find your book. If it's not with you, I would go get it. There's a couple things we're going to do in the book. Page 16. And you should see a small topic on function composition. Now, the book actually calls it Composite Functions, which is actually the same idea. What I'd like you to do is actually read a small paragraph under that heading, Function Composition, and then take a look at Example 8. And of course, as you read and look at Example 8, try to understand it. And maybe you'll say, yeah, I remember this. And then we'll meet you back here. Now, if you're still listening and have not paused the video, you need to pause it. As a little follow-up, the book does not use all this notation, but it's the same idea. When we talk about function composition, we're always talking about the idea of f of g. That can be written this way. It can also be written as f of g of x this way, or I can actually say f of g of x this way. There's different ways to say it, but the idea is that you're plugging g into the f function, and that's what you should have seen them do in example 8. So, what if I ask you to take the same functions that were in the problem? So, in case you didn't catch it, it's f equaling x minus 7, it's g equaling x squared. What if I ask you to take those and try to find g of f? G of f. Go ahead and give that a whirl. Good time to pause the video. So how'd you do? Okay, some students would rewrite this. Maybe it's just you'd like this notation a little better. It's fine either way. Now we're plugging f into g. Well, the g function is actually the x squared function. What I've done is I've written the g function, but without the x, because the x is now going to be substituted by f of x. In other words, I'm plugging x minus 7 into the g function. Now, I want to be careful that obviously that you plug it in the right way, but also that you use appropriate algebra from this point. And you would not want to just square both of these. Of course, that's a math teacher's nightmare. But if you do want to square x minus 7, maybe the directions say that you're supposed to expand it in the standard form, that's fine. Then you have to kind of think of this as like a FOIL method, or you could use a shortcut. Either way, we end up with a trinomial x squared minus 14x plus 49. So I'd like you to add function composition to your list. And now we're going to switch to piecewise functions. We can talk about piecewise functions. Piecewise functions. Now, I'll share with you that piecewise functions, they pop up now and then in calculus, and you want to be able to kind of comfortably work with them. A lot of times that means you want to be able to graph them. So this is going to be like a graphing exercise. This is what your exit ticket's going to look like. I'm going to ask you to do a few of these. Now, when you graph a piecewise function, it's kind of like you're graphing pieces of an entire function. So we want to try to think about the entire function. We also want to try to think about the pieces. So what I have here is the function 5, the function x minus 2 squared, and the function just x minus 2. With the following pieces, with the following restrictions. And this is what starts to make this more officially a piecewise function. Okay, the first piece is going to be just x less than 0. x between 0 and 2, and then x greater than 2. My approach with these, and I want it to be your approach as best you can, is to try to not use a calculator, meaning don't just type all this in your calculator and hit graph. If you do that, you're going to end up getting all of the graph. In other words, you're going to end up getting all of 5. But we only want 5 that's less than 0. So it's better to kind of think about that as a piecewise function. Now, when we say 5, remember that's the same as y equals 5. So y equals 5, of course, is a horizontal line. Now, what I'm trying to present for you here is how you would also do this like in your assignment. In other words, a sketch is okay. But when you draw a horizontal line, of course, draw it horizontally, and then label the endpoints. Okay, so the endpoint here, well, is going to be at 5, specifically 0, 5. And notice that I even made it an open circle so that we can get it all correct, that it's not going to equal 0. So since it's not equal to 0, I'm open at that point. Okay, so far so good. We have a sketch, okay, and we labeled the endpoint. Y equals x minus 2 squared. Now you're probably not alone if you're like, I wish I could type that in my calculator. Just be aware, if you type that in your calculator, you're going to see all of it. I'm trying to get you to a point that you can do this without a calculator. Some colleges still do that. So what do we know about x minus 2 squared? Well, first of all, something that's squared we should know is a parabola. If you're subtracting, that's a shift. Remember talking about shifts? And when you subtract on the inside, it's actually a shift to the right. Now, what I'm talking about is the vertex. So we've got a vertex of a parabola, okay? And I'm going to label it as 2, 0 because, I thought about it. So maybe I should label it. Who knows if it ends up being an endpoint. So, okay, I got a vertex of a parabola. Now, I'm just kind of loosely sketching a parabola. Notice that I'm not making it a solid line yet because I don't know what piece of the parabola I'm going to end up with until I start to think about these endpoints. Now, check this out. It's not hard math, but it's really helpful. If you take the endpoint of 0 and plug it in, you will actually end up with the x and the y value that goes with 0. So if you plug in 0 and you square 0 minus 2, you get 4. Now, folks, 4, 0, 4 is actually the endpoint or maybe the beginning point of this parabola. Now I can start to see a little more about how this parabola is going to connect between the dots. Speaking of the dots, maybe we should plug in, not maybe, but we need to plug in the other endpoint. So we'll plug in 2. Now remember, when you plug in x, you get the y value. You should be realizing that has already been found. It comes out to be 0. Well, that's the other endpoint. Okay, so what we now have is the ability to connect these dots with a piece of a parabola. A piece of a parabola. Now, I tried to make it a little curvy. Okay, it's just a sketch, but it should show that type of contour. Okay, and I labeled the endpoints. X minus 2, y equals x minus 2. Y equals mx plus b. Okay, so again, before you just get your calculator out, you should know how to graph y equals x minus 2. It has a y-intercept of -2. It's got a slope of 1. You start to think about that graph. Now, whether you draw it or not is kind of up to you, but we have a tilted line. This concept of plugging in is very, very helpful. I almost want to say you need to do that. Now, if you're saying, but I can't plug in 2, you got to understand that this is just going to be the spot where my graph picks up. So I can plug in 2 and see what's going on, actually get 2, 0. Now, what that means is that my graph is going to pick up where the other one left off. And so this straight line that I'm kind of drawing, now it begins, now my straight line begins, and of course the piece of that line continues to the right. It continues greater than 2. Probably should get rid of or make sure that it's not emphasize the rest of my graph that wasn't part of the piece. Okay, now these two guys right here didn't connect. I know you've seen this before, but that's okay. These two did connect. Okay, don't assume. Find, plug in x to get your y value. What if we want to do one of these, I guess we could say backwards? Okay, in your book, there's a graph. It's on page 15, figure 118. Let's see if we can come up with, the equations for that graph. So it's a figure. It just looks like two little diagonal lines. Okay, if you're like a little frozen, it's okay. That's why we're going over this. This is sometimes a little harder for people, even though I know you've seen it before. So we're trying to write the equations. Now, you can always get yourself ready. How do you get yourself ready? I mean, you can kind of get some space where you're going to fill in some equations. Eventually, we got to do the dirty work here of figuring out how to describe this little line segment. Okay, but it's a line, right? So all lines have slopes. It should be something that you're thinking about. Sometimes the book, it requires you to sort of just look at some points and get your slope. So take advantage of the 0.11. Okay, up 1 over 1. It's okay just to look at it and say you went up 1 and over 1. You should be able to say that the slope is 1. Maybe you want to make that same statement over here because it's also true. You realize that what we're getting at here is the old y equals mx plus b. So we could get a b value by just looking at the graph. Okay, b equals 0. We can just look at it. Y equals 1x plus 0, obviously known as y equals x. Now, when I write down x instead of y equals x, that's even a little bit better, okay, because I already have the y equals. The y equals is this f of x. So when I write down x, that's my equation. You want to make sure you're thinking about the interval. Now, when you do the interval, it's always in terms of x. I can just kind of look at these two circled x values in order to restrict my line. Okay, so I'm going to be between 0 and 1. Now take care of details. It's not equal to 1 as we have an open circle, but the restriction is definitely part of the answer. How about this guy over here? Y equals mx plus b. Y equals 1x plus b. Now, I would imagine that some of you, all of you, can kind of continue this line, and maybe you continue this line and you get the y-intercept. But I want to remind you that there's a method that says that if you plug in, you can also solve for the the y-intercept. Plugging in the point 2, 1 works every time. Okay, so we get our y-intercept to be -1. Careful, well, not careful, but realize that -1 is the y-intercept back here. So our equation is y equals 1x minus 1. Of course, when you fill that into your piecewise function, you can just say x minus 1. Okay, and then when you write your little interval restriction, it's in terms of x. So these circled numbers will make up the other part of that. Okay, but they're both equal. Take care of the little details, and you got yourself your piecewise function. When you come back from lunch, I'll have 2 problems for you to do that are like this. You should get them right, but I'm kind of saying, hey, let's get them right. Let's think about it. It's a pretty important idea to finish up this section. Okay, so we kind of officially end the section, and I'll show you that exit ticket when you return.